In the open ocean, whatever water evaporates must eventually return. Rivers continually wash salt in from the land, but the sea has reached equilibrium now, and extra salt just precipitates out of the solution onto the ocean floor. The concentration of salt in the Dead Sea is almost 10 times higher than the average for the rest of the oceans. This is far too salty for fish and plants, but even here there are some bacteria and fungi that can survive. The Dead Sea's high salinity is because the water is evaporating much faster than fresh water flows in to replace it. Indeed, the Dead Sea has a salinity of almost 34%. If you evaporated 1 litre of Dead Sea water, you would have around 250 grams of salt left behind. And in the whole of the Dead Sea, there are about 37 billion tonnes of the stuff. Ordinary sea salt is 97% sodium chloride, whereas Dead Sea salt is a mixture of lots of different chloride and bromide salts. Ordinary sodium chloride only makes up about 30%. This is still enough to supply the entire population of the United Kingdom, for example, with cooking salt for 70,000 years. Given that a litre of seawater contains around 35 grams of dissolved salt, desalinating the entire ocean would effectively involve removing 45 million billion tonnes of salt. Such a sudden and significant reduction in weight pressing on the seabed would likely trigger earthquakes and volcanoes around the globe. Because fresh water is less dense, the Arctic ice cap, for example, would sink an extra 10 centimetres into the water, creating the largest tidal wave the planet has ever seen along northern Europe, Russia and Canada. A few hours later, virtually all marine life would die as their cells swelled and ruptured due to osmosis, where water molecules would move towards areas of higher salt concentration. They would sink to the ocean floor, but their bodies would not decompose, as all marine bacteria would be dead too. Marine algae are responsible for at least half of Earth's oxygen production, so there would also be mass extinctions on land. Eventually, though, the world's oceans would slowly restore their salination levels when minerals are continually dissolved from the land by rivers and carried to the sea. But this would take tens of thousands of years. All seabirds do drink seawater, yet birds have less efficient kidneys than mammals, and so excess salt is surprisingly even more toxic to them than to humans. Seabirds cope with this by using specialised salt glands next to their eye sockets. These look like miniature kidneys and work in a similar way, pumping salt ions out of the bloodstream against the normal flow of osmosis. The extra salty water drips down the side of their beak. As Archimedes showed over 2,200 years ago, the trick lies in boosting the density of the bathwater until it exceeds that of your body. The easiest way to do this would be to add salt to the water, but it would require a lot of the stuff, around 30 kilograms in a standard bathtub.